Hi, I'm Jared Galina, and today I'm going to be presenting on my results while investigating and modeling used vehicle prices for the Indian market. So the motivation for my project was you could imagine working for some used vehicle merchant. They're doing quite well in the US and they're looking to expand their operations. They pick out the Indian market as where they want to move into, as this is a quite large market and would have a lot of potential for good profits. So the company already has a model for pricing their US vehicles, motorcycles, and automobiles. But they realize there's a lot of market factors that are different between the US and India. So they want us to come up with a new model to predict what would be reasonable used prices to list vehicles for. Jumping into the data availability and source for this project, we were able to find motorcycle and automobile data sets for the Indian market through Kaggle. The motorcycle data set had resale values as well as a handful of other characteristics we'll get into later. And the automobile data set was actually acquired from Web Scraping, a used vehicle website for India. It's called Cardeco. And this data set was then somewhat curated and made available on Kaggle that we were able to pull that had a lot of similar characteristics to the motorcycle data set, as well as some additional fields that we'll get into later. So looking at our data, the motorcycle and automobile data sets both shared a handful of parameters. These are listed on the right pane at the top. So you can see that brand, selling price, owner type, seller type, new price, year, and kilometers driven. The one exception is brand was not explicitly in these data sets. It's essentially just a parse down field of the full name that was present in the data. So what I've done is just chopped off the first word and used that as a brand name. Then the automobile data set also had a handful of additional fields that weren't present for the motorcycle one. So those are things like fuel type, transmission type, mileage, engine, max power, and the seats. One thing to note is that both data sets were missing a pretty high number of the new price fields. I figured that this would be pretty useful for predicting the resale value. So I went ahead and dropped all of the entries that did not have this field. This still left us with about 900 motorcycle and about 9,000 automobile samples, so we're still in pretty good shape after that. Some notes from the EDA process is that first off, we found some extreme outliers for our resale price. Cars over $100,000, motorcycles over $50,000. The raw values were in rupees. I've converted them to US dollars approximately just to save us a little bit of time and interpretation. So these extreme values for the resale price, I went ahead and omitted from our analysis. These particularly niche and high-end vehicles would likely need a special inspection and therefore shouldn't be handled by some general model. Additionally, I did find some examples where the resale value was higher than the original price. Either this was erroneous, or maybe these were collector vehicles, not super sure, but I went ahead and omitted these as any form of like collector vehicle like that would probably also need an independent assessment and not being fitted by a general model. Finally, the brand field augmentation that I did was not enough. I actually found still a very wide variety of brands present. So I went ahead and grouped these even further into vehicles originating from Asia, Europe, or America. However, even after doing this, I found that there was such a small sample for Europe and America for the motorcycle data set. I'm talking like 6 samples. I went ahead and omitted this feature from further analysis for that data set. Next, I also found that for the owner type in the automobile data set, there were only first owners, so there were no second or anything beyond that. So I went ahead and removed this from the automobile data set. And I also found that there were only a handful of samples from individuals later than the first owner for the motorcycle data set. So I went and made it 2 categories, either first or later than first. Then in the auto features, I also found that engine size and horsepower were very closely related. horsepower being the max power field, but it was measuring horsepower. So I went ahead and only used horsepower, and I found it actually worked best with two categories, one being above 175 horsepower as a threshold, and another category of being below. After that, I also found that the motorcycle dataset only had 3 samples from dealers for the seller type. All the others were individual, so I omitted this field as that's not a sufficient sample size. And finally, in the motorcycle data set, I found some resale prices were extremely low, like ridiculously low, less than $1. So I removed these as well. Whatever's going on with that would likely need to be handled on a case-by-case basis as well. So now jumping into building our motorcycle model, the features we were left with were new price. We expect this to positively correlate to resale value. More expensive vehicle would probably resale for more. Next was year, again, positive because we expect newer vehicles to resell for better prices. Owner number, we expected first owners to get a little bit better prices on their vehicles just because it's desirable to have a vehicle with less owners. And then kilometers driven. So we expected a negative relationship here, as the more wear and tear on a vehicle, the less it should resale for. The fitment is seen on the right. We achieved all of the signage on the coefficients we expected, and we see we got a pretty good fitment on average with an R squared of 0.9 and a mean sigma of 13,000 rupees. And this may seem like a lot, but it's actually only $170. So that's pretty good. Moving to the automobile model, we had a lot more features to work with. We expected pretty much the same signage for the features that were shared with the motorcycle model. But then looking at the new things present, we expected that the fuel efficiency indicated by the mileage field would actually have a positive relationship because a more fuel efficient vehicle likely would have a better resale value. We also thought that the transmission type being automatic would give a little bit better of a resale value. People tend to prefer driving automatic versus manual, unless you're really into cars and driving manual in particular, but on the whole, automatic's easier and typically nicer for the average individual. Then looking at the origin of vehicles, we expected that American and Asian would actually be a little bit better of resale values than European, just because European vehicles likely have higher maintenance costs, are a bit more difficult to get serviced, so a little less desirable unless you're custom ordering it for yourself, and that's not a resale then. We also thought that the seller types of some form of dealer would bump prices. So there's a standard dealer and a Trustmark dealer. Trustmark dealer essentially gives you an additional warranty to buying the car. And then looking at fuel type, we expected that petroleum and compressed natural gas would actually give a bump in resale value versus diesel fuel. This being that petrol is a bit cheaper, easier to find, and compressed natural gas being a unique feature for vehicles likely would help resale value. And then we also thought that vehicles with a horsepower greater than equal to 175 would possibly decrease the value. And this is just like an overly powerful car for typical Indian traffic. A lot of it is like bumper to bumper and not any like crazy highways like we have in the US. And finally, we thought that the seats field might bump price. Larger vehicle like a van or something might have a better resale value than a smaller sedan. With our initial model, we got a sigma of 174,000 rupees and an R squared of 0.76. But more importantly is we noticed a few of our coefficients were not the sign we expected. Specifically, the fuel types both had different signs, and the seats also had a different sign. Additionally, the horsepower range did include 0 in its confidence interval and also had the opposite sign. And same for seats, it includes 0 in its confidence interval. So we went ahead and removed those 2 fields and looked further at the fuel type and the mileage. So we needed to address why we were saying this. So I went and looked at the raw price of vehicles versus their fuel type and saw that diesel was actually having a higher overall average resale price. And so that was actually what was causing our coefficient to be slightly different than what we expected for petrol and compressed natural gas. And then we also saw that the most efficient or most fuel efficient cars, the mileage field, which also had a coefficient that was the opposite sign of what we expected, actually had the lowest resale price at these very high fuel efficient cars. And I expect that this is partially due to these cars probably being budget in the first place. So you want to be fuel efficient, you're probably not buying an expensive car in the first place. So that is why this is probably a suppressed coefficient. So moving into our final model, we've removed those fields we mentioned and left in all the other features as we were able to explain the opposite signs we saw. And we got a new model, pretty similar performance. The sigma error was about 2,000 US dollars, so still pretty good, but not as exceptionally good as the motorcycle model. So next we compared the models we created to their null model versions. And in both cases, we used a log normal null model. That way we weren't getting zero values for the resale price. That wouldn't make sense. And in both cases, we saw multiplicative factors of improvement using our model versus the null model. In the motorcycle case, we had a 4 times improvement on our bounds, and in the automobile case, a 3 times improvement, give or take. Next, we looked at how well our models generalized. So we went ahead and ran cross-validation and found that the motorcycle model generalized pretty well on average. Our 95% Bayesian confidence interval was 9,000 rupees to 22,000 rupees. So a little bit of spread there, but nothing too unbelievable. And then for the automobile case, we saw that our 95% Bayesian confidence interval was proportionally more compact, with a range of 164,000 to 187,000 rupee error. Then we also looked to learning curves to see if we had enough data for both data sets. You can see these plots on the right. For the automobile data set, we had more than enough samples. You can see we're starting to level off our test performance at about that 40% mark. For the motorcycle model, we see it's leveling off towards the end, but perhaps we could squeeze a little more performance out. So maybe a little bit more samples would be good, but we're not going to see a huge improvement from any additional samples, most likely. So now moving on to predictions, I went ahead and predicted 2 motorcycles. I wanted to see how well it would perform in the Indian market and the US market to see whether or not we had truly learned something unique for India in this model. The error we got for the first motorcycle predicted on the left, which is a Royal Enfield in India, was an error of only $8 on a vehicle price of 980. So very good performance. For the second motorcycle, we predicted another Royal Enfield, but this time in the USA. And we underpredicted by about $1,300 for this true resale price of $6,000. So clearly it seems the model has learned something for India. For automobiles, we found that, or we ran a similar experiment where we predicted a vehicle in India and a vehicle in the US. For the vehicle in India, we had an error of about 700 USD on a vehicle price of 3,000 USD. Again, bigger error than the motorcycle, but nothing too terrible. This doesn't seem to be a high bias region necessarily. And for the USA vehicle we predicted, we got an error of $1,300 on a vehicle price of $15,000. So in this case, we're also off, but it doesn't seem like there's as distinct of an improvement for these 2 samples for India specifically. So some final remarks. We saw, at least in the samples we tested, a little better adaptation for the motorcycle model in the Indian market. And we found that both underpredict for the US samples. Overall, we were able to create fairly effective price prediction models for both market segments in India, automobile and motorcycle. And they both seem to generalize pretty well. So they should perform pretty well in actual deployment. And both were able to outperform their null model predictors. So definitely a boost in performance and worth using the model over some form of null model. And that is it for my presentation.